Welcome to Brain Vision.
We begin this question by setting up our reference frame and then applying Newton's second law to the box. So I will choose my reference frame as follows. Everything that is pointing up is positive, and everything that is pointing to the right is positive. So, as a consequence, everything that is pointing to the left will be negative, and everything that is pointing downwards is also negative. Now, we proceed to apply Newton's second law to that box. So, let me call this vertical axis the y-axis and this horizontal axis the x-axis. So, now let us apply Newton's second law to the vertical axis to the box. So, the net force that is acting on the box on the vertical axis is equals to the mass of the box times its acceleration in the vertical axis. So, in that axis, there are two forces acting on the box. The normal force that is pointing to the positive direction and the weight force that points to the negative direction. And this is equals to the mass of the box times the acceleration of that box. Now, note the following. We can calculate the normal force as the mass of the box times the vertical acceleration of the box plus the weight of the box. Now, remember that the frictional force that acts on the box, the absolute value of that frictional force is given by the kinetic frictional coefficient times the normal force. Therefore, the frictional force is equals to the kinetic frictional coefficient times the mass of the box times the vertical acceleration of that box plus the weight of this box. Putting in some values that the problem gave us, the frictional force is in general equals to 0.36 times 6, which is the mass of the box, times the vertical acceleration of the elevator plus the weight of the box. Now, for the weight, remember that the weight is given by the mass times the acceleration of gravity. And the acceleration of gravity is approximately 9.8 meters per second squared. So, we have 6, which is the mass of the box, times 9.8 to compose the weight of that box. And this is our equation for the frictional force in this situation. Now, all we have to do is apply it on each item using the respective acceleration. So, for the first item, the elevator is stationary. So, in this situation, the vertical acceleration of the box is equals to 0. Because the elevator is stationary, so the box is also stationary on the vertical axis. It still moves on the horizontal axis. Therefore, the frictional force is equals to 0.36 times 6 times 9.8. This is because this term is equals to 0 when the acceleration is equals to 0. So we are left with this term times 0.36. And this gives us a frictional force of approximately 21.2 newtons. So this is the answer of the first item. Now, on the second item, we have an acceleration that is pointing upwards, so it's a positive acceleration of 1.2 meters per second squared. Then, in this situation, the frictional force is equals to 0.36 times 6 times 1.2 plus 6 times 9.8. And this gives a frictional force of approximately 23.8 newtons. So this is the answer of the second item. And finally, on the third item, we have an acceleration of 1.2 meters per second, but this time the acceleration is pointing downwards. So in our reference frame, it's a negative acceleration. So now minus 1.2 meters per second squared. And this gives us a frictional force of 0.36 times minus 6 times 1.2 plus 6 times 9.8. So the frictional force in this situation is approximately 18.6 newtons. So this is the answer for the third and final item.